Okay, I think we should start. Good morning or good evening, everyone. Welcome to today's Luohan webinar. I'm Xijie, the moderator for today's webinar. So in today's webinar, we are very happy to have Professor Kristina McElheran from University of Toronto to talk about the very important topic nowadays, which is the rise of industrial AI in America, the microfoundation of productivity J-curves. So Professor Kristina McElheran is an associate professor of strategic management at the University of Toronto and Rotman School of Management. And she was trained in managerial economics and strategy. Her research examined the impact of digital technologies on firms and workers. Um, so far, she has been focusing on the rise of commercial internet, big data, cloud computing, and more recently, AI, which is like most important topic nowadays, probably. And previously, before she's working at Toronto, she spent 6 years at Harvard Business School, and to work at two Silicon Valley startups. And her research has been published in leading journals such as AER and Management Science, so on and so forth. So without further ado, please join me to welcome Kristina. The floor is yours. You have about 1 hour.
Great. Thank you so much. Thanks for having me. Thank you all for joining and giving up what is mostly an evening for you. So I appreciate that. I'm happy to answer questions as we go. So please ask away if I'm confusing or need to provide some useful detail. This is joint work with MJ Yang at University of Colorado and Zachary Croft, who is now at Analysis Group. He was at the U.S. Census Bureau when we worked on this paper, and Eric Brynjolfsson of Stanford University. I have to put my disclaimer on at the front of everything that everything here has been vetted for to protect the privacy of the firms because their response to the surveys is mandated by law in the U.S. That is going to limit some of what I can tell you, unfortunately. What I'm about to show you today is already fully half of our privacy budget for this project. So additional robustness and cuts of the data are going to very quickly erode that budget. So some of what I'm not showing you today is on purpose because we're trying to keep some degrees of freedom for going through the journal review process. Okay, so the common view of AI right now is that it's like a speeding bullet train and it's coming through the economy at lightning speed. But the current reality, as far as I can tell in firms, looks a lot more like this. That things are kind of chaotic. There's experiments going on. It's hard to know what combinations of things should go together. And this is something I've been studying for a long time. So I have a 2015 publication in Management Science that talks about the cost of closing the capabilities gap with the internet. And so our view on this is that what we saw with prior waves of technological change is happening again. And it's because adopting technology in organizations is just hard for reasons that don't have to do with the technology per se, but are deeply embedded in organizational processes. So we're at this time of very, very rapid technological change. I spent a little time thinking about how did we get here. We had this surge of digital technologies come through as early as the late 1960s and 1970s with mainframes and databases, and we got into desktops and PCs in the 1980s. Enterprise software comes through and provides this backbone for firms to manage a lot of processes digitally and using information technology to both communicate and understand what's happening inside and between firms. The internet comes through, as we all remember, in the 1990s, very, very quickly. And I think that was a bit of a shock in terms of how fast the adoption diffused through firms and households across the world. And the pace of change has not slowed. And we get the Internet of Things, broadband and mobile, social media. Now we have these digital artifacts of our social interactions, big data and cloud computing. The deep learning revolution comes through and can make sense of data in ways that we never could before. And now everyone's talking about generative AI. Gordon Moore famously said, the pace of change has never been this fast, yet it will never be this slow again. And so we're in this funny moment of realizing that things are awkward and taking time and also speeding up at the same moment. So this is, the motivation for this study. Eric and I have been studying technology for a long time, and we saw this coming and wanted to get in front of it. So we started surveying firms in the US about their use of AI. What I need to flag for you all in this current conversation is that I'm going to be talking about pre-generative AI today. So the large language models that are the topic of conversation today came through, no earlier than the end of 2022, and our study ends in 2021. So we're not able to tell you about what's happening with large language models, but I think it's super useful, or other foundational models for that matter. It's super useful to keep in mind that other technologies are in use in firms. They're still having impacts on productivity, they're still having impacts on labor, and that part of the challenge for firms is not just the organizational adaptation, but also reconfiguring the technology and the technological context as well. So I'm going to talk a little bit about that, because one of the contributions of this paper is not to just ask about AI, but to have a pretty holistic view of the other technological investments and practices that are taking place in these firms. The challenge here, of course, is this is all happening very fast. It took 10 to 20 years for a big change in the early days of mainframes and databases, sped up to 3 to 5 years in the internet age, and now we seem to get a new step forward in capability every month, or I don't know, are we up down to weeks now? It's a fast moving technological shift, while organizations are basically still moving at a snail's pace. And this is not new. We've seen this with major technological changes in the past. This is a picture of the steam engine in the Centennial Exhibition in Philadelphia, the World's Fair in 1876. And this was first invented in the 1600s. James Watt patented the steam engine in the 1780s. And then by 1838, only 5% of all power in the US was produced by steam. And so you can see, and not until 1870, that the amount of power in US generated by steam matched that generated by water. So you can see, this took 100 years for it to really diffuse and impact the productivity across the US economy. Now, that was a long time ago, but it's interesting to keep in mind that the change of new technologies has always been slower than the advance of the capabilities in the technology. Bresnahan and Trachtenberg are probably best known for studying this phenomenon and coining the term general purpose technologies, and this idea that they improve over time and they spark complementary innovation. I think maybe the conversation is converging on AI being the latest one of these types of technologies. Some folks still want to debate that. I don't want to debate that today, but what I want to do is argue that this lens is very useful because it helps us focus attention on the tasks, the process, and the organizational redesign that are necessary for this to unfold and change how firms operate. And increasingly, I have some colleagues at U of T who've been writing about this. I've been writing about this since early in my career. Chris Foreman, Avi Goldfarb, and Shane Greenstein wrote about this. Shane Greenstein was my advisor. He and Tim Bresnahan talked a lot about the interconnections in processes in firms that have to come up to speed to use new technology. So, before the seminar started, we were talking about the task-based model. If we think about AI affecting a task, well, you quickly understand that a task is embedded in a process, which is embedded in a firm, which is embedded in a value chain, and these systems can only operate as fast as the bottleneck. And so when you apply a technology to one, weak point in that system, what happens is not that the whole system suddenly speeds up, it's that the bottleneck moves to the next slowest spot. And so these weak links move in systems, and until we can get system level redesign and reorganization, it may be very difficult to exploit the benefits of these new capabilities. Doing this takes inspiration. There's a lot of innovation and co-innovation and co-invention, exploration of the unknown that needs to take place. It's usually expensive and it's usually time consuming. And this theory of technological change has very distinct implications. We should expect that we will see delayed and uneven economic impacts. And so that's what we started to see in a prior paper. This was published in 2024 in the Journal of Economics and Management Strategy. We conducted a study of basically the US economy. The survey we designed was sent to 850,000 firms across the US in every sector outside of farming, asking about the use of AI in 2017. And what we found at a time when McKinsey was warning that 80% of firms were using AI, we're a lot closer to 8. Only a very small percentage of respondents used any of these technologies by 2017. And we asked separately about automated vehicles, machine learning, machine vision, natural language processing, and voice recognition. And we also asked about the intensity of use so that we could really differentiate not just the extensive margin of adoption, but how intensely firms were using this. And what became very clear is that any use was down around 6% if we weighted by size, by employment. It maybe went up to 18 or so, but the rates were much, much lower than people expected. And the first reaction I often get to this study is, well, that was a long time ago. Surely things have changed. And yet the census has been running this Business Trends and Outlook survey, BTOS, for many years, including, very, very recently. I just saw a post about it yesterday, actually, showing not only has this not taken off, it's grown very, very slowly. And in fact, maybe in the latest wave is starting to decline. And so there's this real gap between the popular conversation and expectation around AI use and what's really happening in the production processes of firms. And I think the thing I want most to set you up with here from that study, and I'm mentioning this study because we're going to actually use that data in this study as well, because we combine across years, is that this is very uneven. So if we look at the largest firms, the firms that are in CompuStat, the firms that are clients of McKinsey, even though the average AI use might only be about 6%, as early as 2017, the majority, over 62% of large firms were using it. And so I want you to understand that I'm going to talk a lot about averages, but the average effect may not be experienced by very many firms. That this is a very uneven activity, both in terms of adoption and in terms of impact. So super skewed and a lot to unpack here. So the question we wanted to address in this paper is, what are the impacts of AI use on firm performance? And I'm emphasizing this S because I really want to keep that heterogeneity top of mind as we go through this. So I showed you a very quick flash of that 2018 survey asking about 2017. That was the annual business survey. We also have been working with Census to design questions for the Management and Organizational Practices Survey, or MOPS. In 2021, we overhauled the section on digitization and added questions on AI use. So we now have this 2021 survey. We're going to link it to that earlier survey. So now we're going to get change over time which has been very hard to do in this area. And we're going to start to disentangle. I showed you how much of this was driven by size, but we can actually start to see the difference of other organizational characteristics that are very correlated with size. So we can unpack age, organizational complements, and the organizational structure of these adopting firms and establishments. We're going to get a very detailed look of the other technology that's in use, other applications of data, digital infrastructure, capital stock. We even can observe the use of robots for some of this. We're going to triangulate on AI use. So it turns out that AI is actually a bundle of tools and applications. Some of it's embedded in software, some of it's embodied in physical technology. And we're going to use actually a bunch of questions to try to get at this question of adoption. And we're going to learn about the barriers to use, which turns out to be interesting in and of itself, but also useful for identification. And we're going to characterize the population level diffusion in US manufacturing. So this is a manufacturing focused study. We're going to look at correlates of AI use. I'm going to have to skip a bunch of that today, but it's in the paper. And focus, really do a deep dive on the impacts, doing, sort of triangulating through different identification strategies on what we think the causal impact of AI on productivity is and dynamics over time. And as you can probably guess from where I started, what we find at the end of the day is that the adoption remained very low. It did not change super fast, and it was very, very skewed. The other non-AI technologies matter a lot, but I'm going to have to refer you to the paper. I graded out for myself so I wouldn't get sidetracked because time always gets away from me very quickly. I think what's the main takeaway of this paper, and I'm going to show it to you now and then we'll dig into it as we go, is that the short-term effect is negative. And so in a conversation in a world of social media and newspaper articles and white papers and opinion pieces that AI is going to transform the economy, I think it is, but in the short term, it's not in a good way. Like the short-term impacts are negative and they're really negative. They're sort of shockingly negative, and I think we should think about this as a massive adjustment challenge. But it improves over time. And so what we see in the data is this pattern consistent with the J curve. In the short term, we actually see a fall in performance due to the technology use, but the early adopters that survive that downturn actually improve over time. Now, I'm not going to be able to tell you exactly what that shape looks like because we can't pin down the exact start date of adoption because we only have these two cross sections. So we know who has it by the first time period in 2017 and who has it by the second time period in 2021. But that's going to embed different adoption curves for firms that start somewhere before those two time periods. But we have direct evidence of the organizational and process adjustment, and we have a lot of evidence around the heterogeneity. I think what we contribute here is we're measuring AI on purpose. Like this is not coming through some other digital artifact or some other activity that we're observing in firms. Working with the Census Bureau has a lot of advantages in terms of making sure that we don't have selection in the respondents. It's very representative. So we're able to say a lot more about a broader swath of the firm size and age distribution than we can say with publicly traded firms. We're able to do a lot with different identification strategies. So we're able to directly control for a lot of sources of time varying heterogeneity. A lot of us like to use fixed effects strategies to strip out unobserved heterogeneity in firms, but it's so important to keep in mind that that only addresses the time invariant aspects of the unobserved heterogeneity, but things change alongside technology. And so being able to deal with that is a real advantage of our setting. We've just lots and lots of covariates to play with. We're able to do the within estimates, and then we also approach things using a novel instrumental variable strategy. Um, and then seeing change over time is also, I think, a key contribution here. This is very hard. It's very hard to track firms. And so the census data allows us to really do a much better job of following firms and the establishments inside firms over time. Um, all this wonderfulness comes with some limitations. We only, as I mentioned, we only have these two cross sections, so I'm not able to pin down the exact diffusion curve for any firm. We can't see when it took place, and by the time we're doing the within estimates, we are stuck with a balanced panel that's going to push some survivor bias onto what we're doing, and we think that's actually a problem, and we're addressing it in our next disclosure review. I can't tell you too much about it except to say we have done a survival analysis, and there's some interesting findings around, let's just say our concerns are valid, that these adjustment costs don't just show up in the productivity results. Obviously, this study takes place in 2021 when things are moving very quickly. We tried to skip COVID. So if you look at the series of MOPS surveys, they took place in 2010, 2015, and then 2021 because we saw COVID unfolding and delayed the survey. But there's a chance that some of that is unfolding in the background. As I mentioned, people think that adoption has shifted tremendously since then, but the recent study by Bonnie et al. Using the BTOS, and then the one I mentioned on LinkedIn yesterday, suggests that maybe this is not unfolding as quickly as the conversation suggests. We can't obviously disentangle generative AI. It was, given the timing, it was unlikely to be anything more than sort of the older, machine learning and deep learning algorithms that are not these big foundational models. And it's only in manufacturing, which turns out to be useful because it's a lot easier to measure and estimate productivity in manufacturing, but a lot of folks are very focused on knowledge work, and we can't really speak to that in this study. So I think I think the other thing that's useful for studying this activity in the manufacturing sector is this thing I mentioned about system interdependencies. Manufacturing, US manufacturing in particular, is not as modular as you might think because it's evolved over time to have these very often lean, interdependent activities within firms and within supply chains. And so the impact of these management practices over time has been to create responsive and interdependent processes that might make these challenges particularly in the foreground. So it gives us an opportunity to study them in this sector. All right, so any questions before I dive into what we do here in more detail?
Maybe I will ask a clarification question. So, the J curve, obviously, I think there are going to be two components. One is the within firm component, it kind of you mentioned. Another is the between firm component. To what extent, like maybe the later part of J curve is captured by new firms, where the earlier part of firms, like they couldn't really adapt it, they kind of struggle a bit, and more often they die along the way. So could that be something you could test? Maybe not with this data in the next round of a survey or something.
So I'm going to show you some differences by age. So
Uh-huh.
age is a very important driver of the adjustment costs. So your intuition is right that older incumbents suffer more adjustment costs. So at the more aggregate level, we're going to see more younger dynamic firms, and I'll show you ones with specific strategies grow better, grow faster. And so yes, at the aggregate level, that curve is going to include more, the upside is going to include more startups.
Okay.
But at the same time, large firms So this is a tricky thing. Large firms are often older. Older firms are often larger, not always. And they have scale advantages and they have resource advantages. And so it's really important here to try to disentangle size and incumbency in the data. So we do include controls for size and all of our age estimations.
Okay.
Yeah, well let's sort of get into that and then we'll
Yeah.
come back to that. Yeah. So, the thing we first had to do all this is to measure AI use. And so we worked with the US Census Bureau to design and field a brand new survey. Now, keep in mind, we started thinking about how we would ask firms about AI use before 2017. Like we started designing these questions back in 2016 when AI wasn't a thing. And so we were scrambling to find language that would make sense to lots and lots of managers over time. Um, the results I'm going to show you today are actually from an establishment level survey. So this is going to plant level managers. We do some things to roll up to the firm level, and we have to do the firm level analysis. It goes to 10% of all the plants in the US manufacturing sector, but it's covering in the certainty sample over 70% of the sector. So this is a direct observation, which we then can weight to be quite representative of the whole population. The response rate, because of the legal requirements, is 68%, which is unprecedented compared to other surveys academics tend to run. We don't, without the weight and power of the US government, we don't get this kind of response rates. So I think that's a distinct advantage of our data generating process here. As I mentioned, this was the third time we've done it, so we've gotten better at it over time. And what's interesting here is the coverage that we get. So this is the summary stats for the ASM MOPS sample. It's about 28,500 establishments in every sector, in every industry in the sector. And the mean is only about 171. So just to contextualize this, if we're comparing to a study using CompuStat data, the mean in the CompuStat data is 4,000. And so if adoption is skewed by size, you can see that focusing on public firms is really going to push you into that part of the distribution where AI use is much more likely and much more prevalent. We have a much more comprehensive view of the size and age distribution. So here you can see that the mean age is actually quite advanced at 20, almost 29. So there are a lot of older firms in the economy, and if age matters, that's going to impact, how the averages unfold in our estimates. To understand what firms are doing with AI, we ask about the use in specific business functions. So we look at production scheduling, quality control, equipment maintenance is a big application, supply chain and sales forecasting. Then we also ask about specific uses of the technology, like speech recognition, machine vision, automated guided vehicles, and AI in robots. And so this gives us a lot of ways to make sure that the respondent has opportunities to think of different ways that AI could be, coming into the production process. A question I get a lot when I present this paper is, what if they don't know? And I think then it's important to recognize that if they were using it accidentally in a way that was seamless and invisible and productive, that would work against finding any difference between the treated firms and the untreated firms in the sample. So I think that works against significance for us. And so I'm not super worried about that causing a systematic problem. We test this extensively. Like I said, we triangulate. I can't show you all the breakdowns by these categories because of the disclosure avoidance rules. I'm actually going to skip over this. I'm not going to spend a lot of time on this. I've been studying technology for a while, and I'm very concerned that, firms go on a technology journey, that they start with digitization and descriptive analytics. Then as they get better and competition gets harder for these activities, they switch into predictive analytics, and then they get into artificial intelligence. And we don't want to be thinking about a firm going from nothing to AI as the same as going from, really intense use of prediction in their production process using, you know, logistic regression and AI. And so we're very careful in the study to make sure that we measure that technology context as well. And so what we find actually in the US manufacturing sector that digitization is very prevalent. So over 91% or so have at least some information in digital format. There's a lot of cloud computing use. There's a lot of descriptive analytics use, 73%. 65% are using statistical or algorithm-based models that analyze historical data and current data to make predictions. And we distinguish that prediction using older tools and techniques from a machine-based system that can perceive and learn about its environment and then make relevant predictions, recommendations, or decisions for an objective that is determined by humans. And so this is really focusing on the approach to prediction that uses, machine learning activity that can perceive and adapt. And the clause about determined by humans turns out to be very important because managers, if you ask them if AI is actually taking action in the firm, they are very resistant to that idea. And so maybe in a world of agentic AI that will shift, but that was not true at the time of the survey. And you can see that being as generous as possible about what adoption means, we're still at only 23% adoption in a pretty technologically advanced sector of the US economy in 2021. We asked about the barriers to adoption. So the leading response to what would be slowing down or preventing AI use in firms was cost. I think the more maybe conceptually interesting one is that a lot of respondents said we don't have a use case for that in our firm, that figuring out how AI actually applies and closing this co-invention gap is a massive challenge. So just under 30% reported that as a challenge. The level of AI expertise or skills at the establishment was also, relatively important. It's about 12% here. And we were very worried at the time about employee attitudes or government regulations being barriers, and those turned out to be less of a big deal. We're using this skills gap as an IV, and given time, I probably won't be able to get too much in the weeds there. But what happens is if we turn this around and say, if we take the reverse of the expertise barrier conditional on having a use case, we're able to use this as an instrument for adoption. It's going to pick up firms that don't experience the skills gap and adopt, and it's going to give us a little bit more exogenous variation on the uptake of AI because of the timing and the speed at which this happened. Having those people inside the firm was something that predated the arrival of the AI. And it also tells us something about maybe they were able to access this expertise outside the firm. It did not provide an obstacle, so they went ahead, but maybe they had some extra adjustment costs to be borne. And so I'm going to show you a little bit about how that gives us an average treatment, a local average treatment effect that's actually extremely negative. And so we can start to think about who's at risk of adopting, who gets tipped over on the margin, and what those marginal firms experience as one way of thinking about a causal effect. I want to flag for everybody that it's really weird to think about treating firms exogenously with technology, that we don't go through and do randomized controlled trials where you get this technology and you don't. And so if we think about trying to do that in firms, it's actually a weird mental experiment to run. And we might want to think that actually we care a lot about self-selection into technology use for understanding how it's going to really play out in the economy. So we can talk about that when I get there. As I mentioned, we have lots of other controls. We're looking at size, IT capital, energy, capital stock. labor skills in terms of the education of the employees, the multi-unit status, whether it's a headquarters, all the other management practices from the MOP survey, unionization, the production process design is an innovation that I added to the MOP survey actually in the prior wave, where we can think about whether it's a flow efficient process that does a small number of products at very high volume versus a jumbled flow process that makes many things at much lower volume. These turn out to be very different physical production systems with very different management practices, different economies of scale, and different levels of stability, which matters if we're thinking about using past data to predict future performance. These are different systems of production, and they behave very differently in terms of how we use technology in them. We also control for e-commerce intensity, and we can look at prior value-added growth before the survey. So in the interest of time, I'm just going to zip sort of quickly through this, but it's interesting to notice that prior technology predicts AI use differently. So as I mentioned, using prediction seems to be a very easy on-ramp to AI, but firms that are leaning heavily on descriptive analytics are less likely to use AI. And this is either telling us something about their lack of readiness on that journey or a substitution between description and prediction. And so I think we should keep in mind that AI is not a silver bullet for every firm in every context, and they're solving their technology needs in different ways. Let's see what else is useful. This is just showing that the first stage of our IV works. So not having this skill barrier does predict AI use, conditional on a lot of things. We see interesting interactions with management practices. So firms that have very structured lean manufacturing practices are more likely to adopt AI unless they're doing lots of high-powered incentives for their people. And these structured people management practices are actually working against the adoption of AI. And we actually saw this in a prior working paper. It's not circulating widely, but I presented it a few times, where we see super structured management practices hindering the adoption of new technologies. And there's something about the organizational slack that I think is interesting, and it's going to probably be the next paper. And then we see that there's this negative relationship between the labor productivity in 2019 and the adoption by 2021, which is just sort of giving you a preview of what we find when we look at the performance implications. This is just an OLS specification where we control for lots of things. You can see if we do, so the dependent variable here is log value added, and controlling for descriptive analytics, predictive analytics, and then you can see down below as we go across columns, we're adding controls. We have an index of these different AI uses as our main explanatory variable. And my favorite specification is over here in column 6, because we're controlling for the IT context, we're controlling for size, multi-unit status, the skills, the structured management, plant type, plant age, capital stock really matters here. And I'm going to flag this because often we can't observe the accumulated and depreciated capital stock in firms, but the census data lets us do it. And very detailed industry controls. And so I thought I had another, there we go. If you look across columns here, if you don't do those controls, you can see a positive relationship between AI and performance. But as we layer in the controls, as we in particular add in the capital stock, we find a statistically significant and economically large negative relationship between AI use and productivity. So what this is saying is that amongst the firms that chose to adopt, so this is selection into treatment, the cross-sectional relationship controlling for lots of things between AI use and performance is bad. It's negative, and to have over a percentage point of productivity loss is actually a pretty big deal. So if I had shown you a positive coefficient, you probably rightly would have said, oh, it's upward biased because the firms that are going to choose to adopt are the ones that are most likely to benefit. And I will say, you're right. So not only is this negative, it is probably still too positive. That the real average, causal effect here is significantly worse than what we're identifying with this one average effect. We checked profits as well, and this is not statistically significant, and it's also not very big. So this is probably upward biased as well, suggesting that the impact is not just on productivity, but it's also on profitability. Any questions there before I start to unpack this average effect?
Just one quick question, why do you regress log on log value added instead of a productivity measure directly?
Because this gives us a much more flexible production function. So if you
Okay.
impose a log linear Cobb-Douglas production function, and then you take that residual, you've got two problems. One, you've put a structural form on the production function that's probably too strong. And second, now you've got an estimated regressor. And so this increases you have to now bootstrap the standard errors to get the standard errors to be right, because your left-hand side variable now comes in with a standard error. And when you do this in the census data with these really fine-grained industry controls, you end up with lots of empty cells, and the bootstrap function doesn't work very well. So then you have to shrink your data set down to only have well-populated industry cells or very broad industry controls. So this is the approach that Chad Severson has used in his productivity studies, Nick Bloom and John Van Reenen. It's a much more flexible approach.
Mhm.
And it's really useful if you can separately control for all these other production inputs. So it requires that you can control for labor inputs, capital inputs, energy inputs, cost of materials. We strip those out in the value added, but you really do need a lot of controls to do this well.
Okay, got it.
Yeah, no, we've many of us who've been doing productivity for a long time have had that question. But this is generally a more robust way to do it. It's a little bit more flexible.
So the
And
size of deployment is in the scale control.
sorry, the
Uh,
size, yeah, the size is in the controls.
okay. Okay, size. Okay.
Yeah,
In terms of employment,
yeah,
right? Okay.
okay. So then what I'm going to show you is what happens. We can take that and match it up to the annual business survey at the firm level. This imposes a little bit of survival and size restriction on us. Before I was showing you establishments. These are firms that have about 344 employees on average, so still much smaller than CompuStat. And you can see in the data here, so in this match sample, the adoption is very much the early adoption of in the 2017 years, very much on par with what we saw across the economy. So around 8% or so here, and then we see a growth over time. So if we do the within firm estimation, so we're assuming here that there's no AI in 2012. So here we're looking at 2017 matched to 2012. And this gives us a very early view of these firms. And so this is asking, if we can control for these within firm characteristics and assume we're going from 0 to some AI use, again, with all these time invariant controls, we see negative returns to AI use that are increasing in the intensity of AI use. Here, profits are also negative. And because we're using the annual business survey, we have this rich set of, we have a subsample of 75,000 startups where we can directly observe their business strategies. So uh, we can see here, oh, I didn't highlight it. Sorry. We can see the difference between a differentiation and quality strategy, new markets, and cost leadership. And so what's interesting to see here is that the negative effect is much lower in innovation focused startups. So the business strategy is causing some different J-curve shapes. But to get back to your question about age, this is where age starts to pop. That um, if we separate into, younger firms and older firms, the average effect is actually positive unless they're older. And so the age effect really dramatically brings down the return. So this is showing the marginal effect on growth over the 4 years against firm age. And so you can see here that indeed the top part of the J curve is really going to be picking up these younger firms. See, I told you we'd get to it. Is that making sense?
Yeah, perfectly.
Okay. Then we can look at what happens to these firms over time. So I said the short-term impact was bad. What happens over time, though, is that if we're looking now, not 2012 to 2017, but 2017 to 2021, where we can match up the annual business survey with the MOPS, we can see growth over time. And the firms that adopt AI by 2017, so they're early adopters and they survive, so they stay in our sample, outperform on every dimension. So we see employment growth, we see revenue growth, we see labor productivity growth. At a time when we were seeing, over the same period, the average employment in the sector was declining. So it was a 1.5% decline in employment. So people are worried about what's happening to employees in this firm. I think I'm going to show you the employment results in an IV setting next. The short term is negative, but we see this growth over time at a time when employment was falling. So to see a positive impact over time is actually quite optimistic. And this suggests that even if we're seeing replacement in the short term of workers in these production processes, over time, it's actually positive for employment. Any questions on that? I see I'm a little low on time, so I'll charge ahead to the IV estimates. So people find things to complain about with every approach. So I showed you OLS, I showed you fixed effects. Now I'm going to show you instrumental variables. And so keep in mind, this is picking up the local average treatment effect for firms that adopt AI and don't report any kind of skill barrier in doing it. So they're kind of these marginal firms that tip into adopting AI. They wouldn't necessarily always be adopters. So they're not the always takers in the Angus and Pischke model. Here we're finding some pretty scary stuff. So one standard deviation higher AI index, if you take this as causal, again, locally causal, would drive a 44% lower productivity, which is a massive productivity hit. I mentioned that some folks wonder whether we've really picked up AI. Well, the nice thing about instrumental variables is it does address measurement error. In fact, in an earlier study using the MOPS, Bloom et al. Went into a very detailed analysis of potential measurement error and found that some of these estimates could actually be downward biased in OLS by about a factor of 2. So if we saw a few percentage point loss in OLS, we should at the minimum expect 2x that just due to measurement error alone. And so correcting for that is probably driving a lot of this very large negative coefficient. We have some other sort of benchmarking in the paper. We're trying to get a sense of whether this is a reasonable estimate. It's big. It's sort of implausibly big as a negative effect that goes across the whole economy. Like we would have seen this have a catastrophic impact if it was happening to all the adopters. And so what we do is try to go in and understand the heterogeneity. What is driving that, negative on average, um, that average effect that's probably embedding firms that are really actually doing quite well and firms that are suffering horribly. And so we wanted to know who's doing better and who's suffering horribly. And the answer has to do a bit with age. So as I mentioned, older firms are suffering horribly. And it also has to do with this production design choice that systems that are designed and operated for stability and flow efficiency do much better. So there, you can see that the second stage effect here is actually not statistically significant, suggesting that production processes that have already been optimized with lots of instrumentation, lots of data availability, and an emphasis on stability. So where the past is going to be a good predictor of the future, they actually do very well with AI and prediction focused technologies. It's the job shops and the R&D activities and the jumbled flow and the high uncertainty that really suffer when they try to move into AI use. We also saw this in our Power of Prediction paper studying predictive analytics that was published in 2021. That was also with Eric. We can go in and do sort of a complier analysis to say which types of firms are sensitive to the instrument and can we say something about their characteristics that may explain this very large negative effect. And what's interesting is if you think about these firms that are kind of on the margin of adopting and they get tipped into adopting, they have characteristics that we would associate with these always takers, firms that are always on the frontier of technology adoption. They have lots of organizational complements. They have lots of tech-related capabilities. They're always going to adopt. And then there's never takers. These are the firms that never adopt the technology because they face either a use case problem or a complements problem. And these marginal firms show characteristics of both. So if we look at the odds ratio of these characteristics for the compliers, you can see that they're much more likely to have a lot of e-commerce activity. They're much more likely to be having robust cloud computing infrastructure. They're more likely to be multi-unit. So they have a organizational structure that embeds lots of units within the same firm. And we have a lot of research, productivity research. Chad contributed to a lot of this, showing that good plants tend to belong to good firms, and these large multi-unit firms tend to outperform on a lot of dimensions. They also, though, these compliers, these marginal firms face a lot of barriers in terms of not having lots and lots of digital information to work from, and then they also are less likely to have headquarters co-located. So they may be lacking some of the organizational infrastructure needed to make this work. And so this is kind of helping to make sense of this part of the distribution that really seems to have high adjustment costs. We wanted to understand more about what adjustment looks like at a detailed level. And so we're able to leverage the data to go in and look at work in progress inventory. So firms that are running really lean tend to have low inventories. And if you're having problems aligning your systems in manufacturing production, one of the things you do to keep the wheels turning is you put more buffers into your system. You carry more work in progress inventory so that if you get any kind of misalignment, you don't have to stop production. You just have to run it less lean with more, inventory fat in there to grease the wheel, so to speak. And so if firms are having trouble reconfiguring things, we would predict an increase in work in progress inventory, which is exactly what we see, a large and statistically significant increase in inventories. If this reconfiguration has to happen at a physical level, we would expect to see more investment in automation and robots inside firms. And so in column 4 here, you can see that AI use is absolutely predicting increased physical automation. And so there's this adjustment in the tangible resources as well as some of these intangibles. And then we are seeing churn in employment. Unfortunately, in the short term, we see a very, very large fall in employment amongst AI adopters. So this isn't just sort of a measurement problem. So some of the J curve effects that we see in the aggregate in the macroeconomy can be due to measurement problems. What we're saying here in this paper is why we're calling it microfoundations of the J curve. It's not a measurement problem. This is an actual challenge of firms having to maybe slow down production because they're trying to keep things in alignment. They have to put more fat in. They need to change robots. They need to change employees. They're reconfiguring how they produce goods. And this is causing them to produce less, to profit less, and to be less efficient in their production. So it's really a multifaceted adjustment challenge that we can actually show at a very granular level. People like to fight about the IV. I fortunately used up all my time, so we can't fight about the IV, but we do a lot of work in the paper to check the plausibility of that. We we wanted to actually dig deeper into why, what to answer the question is what could firms do to mitigate some of these adjustment problems. And one, as I mentioned, is the choice of business strategy. The other has to do with maintaining your organizational practices. So the MOPS lets us see how the plants are managed over time. And what's really notable is that if we look at structured management broken down by process, by KPI review, by awareness and production target, the older firms that are suffering are also kind of falling down in their organizational management practices, that somehow the adjustment to AI is causing some sort of distraction or misalignment with these really well-established lean practices that sort of led to the firm's success. We're challenging the very basis that allowed them to survive and grow for so long. And so, when reporters ask me what should firms do, I say, well, for sure, you got to dial in your management practices, that you cannot let your awareness of what is happening inside your production process and your attention to detailed indicators fall down, even while you're going through this potentially chaotic change. The other thing that is super interesting, and I think helps us think about what we see in the US versus other countries, is that we see spillovers inside these multi-unit firms. So establishments that don't adopt AI, but they belong to a firm where another establishment did, they also benefit. And so in countries that don't have these big multi-unit firms, we might expect very different adjustment costs and long run effects. So I'm at time, and I just want to sort of hit the highlights that we continue to see this low skewed adoption, this surprising and very troubling negative short run hit that then turns around over time. We think we've got some pretty robust evidence supporting direct adjustment costs and not just a measurement problem in thinking about the impacts. Lots of heterogeneity. And like I said, we're going to look at survival next. Reuters covered my talk to the European Central Bank and said, well, what she's saying is if AI doesn't kill your company, it will make it stronger. So I think that's maybe one of the key takeaways, and happy to receive any feedback or ideas. We're doing one more set of robustness results before we start submitting this to journals. So now is the moment to help us strengthen the paper.
Okay, thanks Kristina for the wonderful talk, and maybe I think we can still entertain one or two questions from the
Yeah,
audience.
no, I'm very flexible on time. I know it's late your time.
Okay, so any questions from the audience?
It's a lot to take in, and there's a lot in the paper.
Yeah.
One of the things we'll probably have to do is maybe split the adoption study out it's been accepted into the AEA papers and proceedings for next year. And
Mhm.
so we're going to present it, and then they always like to publish something from that. So we
Okay.
might give them more of a diffusion or adoption study for that publication so that we can um, publish the more detailed productivity study in a top journal. Fingers crossed. Top journal. We all hope, right?
Yeah. And if there's no more questions, let's thank Christina again for the wonderful talk. And I believe everybody learned a lot from your recent study, and we are looking forward to kind of uh, know more about your future work in the maybe upcoming years. And thanks everyone for coming. And so that's the end for today's Luohan webinar. So stay tuned, and we're gonna have a new upcoming seminar series on the related topics soon. Okay, so thank everyone for coming, and thanks Christina. It's a great pleasure.
Thank you. Thank you
You
so much.
participating.
It was
Okay.
lovely to be here, and thank you to all of you for coming and staying late. I appreciate it.
Okay, thank you.
This was fun. I really appreciate it. And I hope it will cross paths in areas.
Because you haven't come to Singapore before, I think I'm gonna invite you to come at least once, maybe in the next few years.
That would be
Hey,
wonderful.
Yeah.
hey, Christina. Sorry, I have a quick clarification question if it's not too late. So,
Oh, sure, no worries.
sorry, because I remember you mentioned in the paper somewhere pretty quickly that for employment there was a first labor substitution, but in the long run, actually the firms that do adopt or the firms that does adopt AI actually will see growth in employment, right? But at
Yes.
the same time, the industry as a whole they will experience a loss in employment, right? Was it clear?
We're not able to so we're not able to tell you exactly what happens to the workers, which is what people care about. I have a paper that was published in 2023 in the Journal of Econometrics, where we worried about what happened to workers when firms digitize. So we're looking at software, not AI. But to answer the question of what happens to the workers, you actually need the employer-employee match data.
Right,
Because all we can show you is in our sample, the firms we observe shed labor, and then we observe that they add labor. But we can't tell you, do they add the same workers back, different workers? Does the industry overall gain, lose? There's a nice paper by Kristina Gathman. Um, that just it's an ISA working paper where they use employer-employee match data, I think in Germany, and they're using industry exposure measures to see to proxy for AI use. So they don't quite have the firm level variation in AI use, but they show that workers do reallocate to different
right,
types of jobs as a in response to the AI exposure.
right. And also, because you explored a lot of heterogeneous effects, right, of the AI adoption. And one potential heterogeneity I would think of is that um, for industries with different IT intensities, probably they will also experience the effects very differently for more IT intensive industries because they have,
Yes. So
right, yeah,
one of the things we will do in our next disclosure is show some industry level statistics. What I showed you, excuse me, at the firm and establishment level does control for the IT intensity at that establishment and at that firm. So we can observe in the data um, the accumulated and depreciated IT capital stock. So the investments in capitalized hardware and software, that's accounted for, that's in the controls. We can look at we're controlling for their cloud computing expenditure, and we're controlling for the extent of digitization and the use of descriptive and predictive analytics. So this is really partialing out at the firm and establishment level just the AI controlling for that. So there's no unobserved sort of technology intensity that's driving the average effect.
Right. But I'm just more thinking, if you do split industries, like if you redo the analysis by different industry groups, and probably we also see some differential effects across this industry groups, right?
Yes. So right now we're controlling for that, and so correct me if I'm wrong, but I think what you're saying is it'd be really nice to see, instead of controlling for the industry, just show us the industry differences, right?
Yeah, because I suppose you could have a ID intensity indicator across your industry codes, right? 3-digit NACE codes. And then probably if you add another interaction term to explore this interaction effect, you might see more IT intensive industries have a stronger impact, for instance.
Yeah, so no, that's a great comment. That's on our radar for the next disclosure, is instead of controlling for all these things, what if we do interactions so you can actually see, what those differential effects look like in different buckets of firms, if you will. No, I appreciate that. It's a great comment. We knew this would be desirable, and we held off because it does chew up many degrees of freedom in our privacy budget very quickly.
Right. Yeah.
We're always doing this thing where we want to explain as much as possible without creating these small cells that would theoretically make it possible to identify firms in the data, because it's a requirement of our access to the data that we protect the privacy of not just of the firms, but even whether or not a firm is in the data. So it's not, could you identify the firm and reverse engineer its characteristics? We need to make it impossible to even tell whether a firm is in our data set or not.
Right.
Very strict.
Yeah. Thanks.
Yeah, no, thank you for your questions and suggestion. It's more of a suggestion, but it's very well taken.
Any more questions? Okay.
Yeah, bring me all your good ideas, because this is the month when we're going to try to do this last big push, and then we really want to get this paper into publication before it's, before agentic AI is all anybody cares about.
Yeah, things are moving very quickly. All right, I think it's about it. Thanks everyone for coming. Thanks, Kristina, for the wonderful talk. And good evening or good morning to everyone. Okay,
Yes,
bye.
thanks again. Take care.
Bye.
Bye-bye.
Bye.